AltTester lets you test your Unity or Unreal games on any target platform, either with scripts or by using your favorite AI tools. It all starts with your game. You add the AltTester SDK and build as usual, and that instrumented build now exposes every object inside the game. AltTester Desktop is your hub. It connects to that instrumented build over a secure WebSocket, either locally or over the network, and gives you an inspector and a recorder for creating scripts. From there, you automate. You can write your test once with AltDriver in C#, Python, Java, or Robot Framework. Alternatively, you can use AI tools to generate the code and run automated tests through the AltTester AI extension. So let's see it in action. We start with an instrumented cooking co-op style game on the left, and the kind of docs most teams already have, a game overview, plus our existing smoke and regression cases. We are using Visual Studio Code here as our text editor and its integrated terminal. The key piece is the command line interface we just released. It exposes the entire AltTester API from the terminal. So any CLI-capable AI tool, like Claude Code, can now drive the game directly. For tools that do not support direct CLI access, like Claude Cowork, AltTester offers the same functionality via an MCP server. One command, install skills, teaches those tools how to use the API properly. I'll install the robot skill, which assumes we're starting from scratch and don't want to write any code by hand. Now we start Claude, Opus 4.8, with its 1 million token context. Here's the prompt. I want to write automated tests for cooking co-op. Please read the available documentation and help me automate the first 2 tests from the smoke set. The game is already running and connected to AltTester Desktop. Claude detects the skill and starts using it, and the skill teaches it how to use the API correctly. It connects to the game, and you can watch it interact directly, pressing buttons, naming the kitchen, setting a chef nickname, Smoke Chef, and finding the input controller. That's the first 2 tests, end to end. Notice what it does next. It works out how to reset the game to a known state, because it knows each test has to start from the same place to be repeatable. It returns to the main menu, then lays out a plan covering the 2 smoke tests, the exact steps from our test cases. It also builds a technical reference of the locators it found, since it knows it'll need them later. And it flags a few discrepancies between the spec I wrote and how the game actually behaves. Which is fair, my spec was a little generic. I'll accept those and approve the plan. From here it generates the tests in Robot Framework, and this is the important part. The output is a deterministic suite. Once it's written, we run it over and over with no LLM involved at all. No tokens, no AI at runtime. Just plain, repeatable tests. Robot Framework runs on Python and reads almost like natural language, which maps closely to the smoke tests themselves. It writes the files in a clear structure, actions, checks, and flows grouped into folders, and builds the tests from those. Let's run it. We use the AltTester command, and we can watch it execute live in the game. Then we get a dashboard report, every step we just ran, all green, all passed. This is our test now, and we can run it again and again, deterministically, as many times as we want. A quick note on cost. This entire session used about 9% of the context, and remember, that's a one-time generation cost. The tests it produced run for free, forever. However, the CLI and MCP tools can also be used in agentic mode, where an LLM is involved throughout the run to decide on next steps. More on this on a follow-up video, stay tuned.